Hi everyone, and welcome back to the Energy Research Lab. Today we are going to be beginning Chapter 2, which we're going to focus on solving the problem for the rescue workers and having ways for them to get energy into the battery. So today we're investigating claims about how objects get energy, and which will then lead us to figuring out ways we can get the energy to the rescue workers. So you should have completed the warm-up, which had a letter from the Energy Research Lab. It says, "Dear student energy scientists, rescue workers need to have working equipment, such as flashlights, at all times. But they can't always just charge their equipment by plugging it in. As student energy scientists, your assignment is to make sure the rescue team's equipment works in any emergency situation. To prepare to help the rescue team, reflect on these questions and record your ideas. Sincerely, Morgan Lewis, Lead Energy Scientist, Energy Research Lab." Now, at this time, if you have not completed the warm-up, I suggest that you pause the video and go and complete the warm-up because the two questions are going to help prompt your thinking about how we can solve this problem for the rescue workers. So, our question is that our problem is that we're trying to have energy for the rescue workers and to power their electrical devices. So we're going to introduce claims or answers that might help us solve getting the electricity to the rescue workers. So the Chapter 2 question: how can the rescue workers get energy to the batteries in their equipment during rescue missions? And now today's question is, how do objects get energy? Now, while we're trying to solve this question, how do objects get energy, I'm going to give you 3 claims that you're going to have to decide at the end which one is true or which ones are not true. So claim 1, objects can make their own energy. Claim 2, objects get energy from other objects that have energy. 3, only living things have energy. Now, before we begin, I want you to take a guess or a hypothesis on which one you think is true. We're going to investigate using the simulator today to try to eliminate some of these claims or to support some of these claims. As a reminder, a generator is one of the devices you might use as part of your energy system. A generator is a machine that can convert or change kinetic energy into electrical energy. Now, this is important because we're looking at movement or active energy and turning it into electrical energy, which is the kind of energy you need to charge a battery. For the demonstration, we will use the sim to get evidence for or against claim 3. Only living things have energy. So I'm going to go into the simulator and then onto the Amplify website just to start and show you how you're supposed to continue. You will be investigating the other claims on your own or in your groups. So I'm on activity 3. And then I said we were going to do claim 3. So I'm going to run the simulator by clicking the blue button, or you could go onto the side and simply turn on the simulator. And I'm going to pick fuel. And then from the fuel, it's going to go to the engine to generator, because I want to turn it into electrical energy. And then I want to charge the battery, just like we would need to be doing for the rescue workers. I'm going to turn it to 100 just to see the full effect, and press run. And let's go back to the Analyze tool. as I can see here, I was able, from fuel, to get all the energy to the battery. I'm going to take a screenshot. If you have an iPad or a Apple computer, you can do a screenshot pretty easily, but you also have the option for using Snippet or something similar on PC and tablets. On any device, you should be able to screenshot your system. I only say that's important because later on you're going to have to add it here. So I delete the old one and put a new one. There we go. That's the one we just created. All right, so let's go back. Let me just refresh my page. I think I confused it by changing my photo. All right. So again, a generator converts kinetic to electrical. And we were working on claim 3. The objects that I used, or the pieces I used here, were fuel, engine, generator, battery. None of these objects are living things. So my claim that only living things have energy is not being supported. My evidence is I used non-living items to get energy to the battery, and I was able to complete the task. This matters because it shows that non-living things can give energy to a system. Therefore, claim 3 is not supported. I'm going to complete another task and do the second one as well. But you are going to choose either claim 1 or claim 2 to complete your task. At this time, you will be trying to either prove or disprove that either one of the claims, claim 1 or 2, as I already disproved claim 3. At this time, you should pause the video and work as a group or individually to try to support these claims. All right, and for those that were able to pause and come back, welcome back. So let's talk about what's going on here. Sorry, let me go to the right page. So we have fuel, engine, generator, battery, and in this diagram I have here light. None of these things are living things. But if you look here, there's 83 energy molecules or energy units, and it goes from potential to kinetic, kinetic to electric, electric potential to electric light. None of these things were, sorry about that, I didn't mean to exit out of that. None of these things were living things, but I also want you to look at the top and look at how the energy is being described. It's changing. It's showing you which direction the energy is going and what kind of energy that you're seeing. Potential kinetic, kinetic electrical, and showing you the steps that the energy is moving through. Now, another part is when you click on the Analyze area, you see the energy and how it was changed through the system. So when we put the energy in with the fuel, we had 97 units. energy that's still in the system at the time that I took this screenshot is 62. And as you can see in here, there's still energy in the battery and potentially energy coming through the engine and generator. Now, there's energy that's transferred out of the system. Just as it was transferred in, the energy can be transferred out. And here we see that most of it was set off to thermal energy, heat. In this picture, you can see that the light is actually not on yet, which makes sense because if you touch a car engine and stuff like that, you start to feel the heat. So these objects, as they're functioning, are releasing heat. Eventually, when the light is turned on, there would be light energy and thermal energy being released into the system. But the energy that's out is the same amount of energy that's put in. So 100 came in on this graph. Let me actually go to the simulator to show you instead of my screenshots. I apologize, just one moment. I thought I had them up. All right, there we go. So here we are in the simulator. I'm going to run and build this again. And actually, I'm going to add the light bulb on this one. I'm going to use the LED light, of course, because we already decided that it is a better system. I'm not going to transfer the energy to the light, meaning I'm not actually even going to turn it on. And you can see I put it in 100. 64 is still stuck inside of the system, either in the battery or in the engine and generator. And so far, 36 units have been released or let go or transferred out of the system. And again, we know that these things get hot because we have experience with cars and stuff like that. So the thermal energy released some of the energy from the system. Now I'm going to go back to the run page and actually transfer the energy to the LED. Now 100 units came in. No energy is left in the system. It was used all the way up. 50 units was turned into light and transferred out as light, and 50 units were transferred out as thermal energy. Again, because we know these things generally get warm. But what's interesting is that the energy stays the same. The amount of energy stays the same. It just turns into different things. And I want you to think about that as you think about possible answers or eliminating certain claims. So let's go back here. I want you to make sure you find either for claim 1 or claim 2, I want you to support or not support a claim and use the evidence and explain to me how your evidence shows that your claim is either correct or not correct. Thank you.